Dear students, in this video we will see chapter 5 arithmetic progressions. First we will see some introduction. So here consider the following list of numbers. See here you are having some list 1, 2, 3, 4 and so on, 100, 70, 40 and so on, like this. So each of the numbers in the list is called a term here. So now we need to find whether this list is in arithmetic progression or not. So if you see this list, the difference between the second term and first term, the difference between the second term 2 and the first term 1 is 2 minus 1, that is equal to 1. And the difference between the third and the second one, 3 minus 2 is also equal to 1. Fourth term and the third term, 4 minus 3 is equal to 1. So the difference between the terms is 1. So here you see the definition. We see that the successive terms, that means the terms one after another, are obtained by adding a fixed number to the preceding terms. That means how you get the second term? By adding 1 to the first term. If you add 1 to the first term, you get the second term. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5 and so on. So in this way we get the series here. So such a series or such a list of numbers is called arithmetic progressions, in short AP. So the number which we add to get the next term is called the common difference here. That means the difference between the second term and first term is equal to the difference between third term and second term, and this difference is known as the common difference, given by the symbol D. So now what is an arithmetic progression? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Of course, first term we will not add anything. For example, if you see here the second series, in the second series here, 70 minus 100, 70 minus 100, second term minus first term is minus 30. If you see the third term minus second term, 40 minus 70 is also equal to minus 30, and so on. 10 minus 40 is also equal to minus 30. So the second list given here is also in arithmetic progression. Same way all the lists which are given here, the examples, these are in arithmetic progression. These series are in set to form an arithmetic progression series. So now we will see some more introduction before we go to the first problem. The fixed number is called the common difference, that is the difference between the second term and the first term. So the series, the arithmetic progression series can be written as something like this: A1, A2, A3 and so on up to AN. These are the terms. A1 is the first term, A2 is the second term, A3 is the third term and so on up to AN. So A2 minus A1 is equal to the common difference D. This is same as A3 minus A2. Here also we get the same number D. The nth term is given by AN, right? So here it is given, see the common difference, A2 minus A1 equal to A3 minus A2 and so on, equal to last one AN minus 1. So all these values are equal and that is equal to D, and that is known as the common difference. So the general form of arithmetic progression, AP series, general form of AP is first term is given by A plus D, A1 also we can say, A also we can say. A is the first term if we consider. The second term how we obtain? A plus D. Common difference if you add. Third term how you will obtain? A plus 2D. Fourth term how you will obtain? A plus 3D and so on. Right? So first term is A and the second term we obtain by adding the common difference D, A plus 2D, A plus 3D and so on. So this is the general form of arithmetic progression: A plus D, A plus 2D and so on, where D is known as the common difference between the second term and the first term, or third term and second term and so on. So A1 is equal to A, that is the first term, A2 is A plus D, A3 is A plus 2D and so on. What about the nth term? Nth term is AN is equal to A plus N minus 1 into D. If you see the fourth term, how we are writing the fourth term? We are writing the fourth term as A plus 3D and 1 less here. So here the nth term is AN. This is known as the nth term. An is equal to a plus n minus 1 into d. So this you have to remember. The nth term of an AP is a plus n minus 1 into d. Then we are having finite and infinite AP. Finite AP, what is finite AP? The arithmetic progression series which is fixed. That means where we have the last term. For example, this is the first term, second term, third term and so on. The last term is this one. So here we have fixed number of terms. So that is called finite AP, fixed number of terms. So in case of infinite AP, here we don't have the nth term here. See, the series is continuous. It is non-ending or non-terminating, we can say. 1, 2, 3, 4 and so on. The last term here, nth term we don't know. So nth term is not given here in the infinite arithmetic progression series. Then we have some formulas, we will see as and when required. This is about the introduction. Now we have here first question exercise 5.1. In which of the following situations does the list of numbers involved make an arithmetic progression? So we have to find here whether the given situations here, the 4 situations are given here as 4 bits. We need to find whether they form arithmetic progressions or not. So the taxi fare here given as the taxi fare for each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. Suppose we are hiring a taxi and the fixed fare is rupees 15. That means once we start we have to pay rupees 15 as the minimum we can say charges there. Then for each extra additional kilometer we have to pay 8 kilometer and so on. So we can write here solution for first bit, taxi fare for first kilometer for 1 kilometer which is fixed here is how much? Rupees 15. This is starting fare, we can say. So for the additional kilometer means what? For the second kilometer, say taxi fare for 2 kilometers. So first we have to pay, anyway we have to pay 15. Then additional how much for each one? It is given as rupees 8. So that is 8. That is equal to 23. Similarly, we can write for 3 kilometers. What we can write? 23 plus whatever is there, 23, and or you can write 15 plus 8 plus 8. That way also we can write. We can take 4 terms here. For 4th kilometer, this is how much? 31, and we have here 31 plus 8, 39 rupees. So now if you see these terms, whether this forms an AP or not, arithmetic progression or not, we have to find, right? So we have to find, does the list of numbers involved make an arithmetic progression or not? This we have to check. So what is the first term? So the series here is first one is 15, second one is 23, third one is 31 rupees, 39 and so on. So what is common difference here? Common difference is A2 minus A1, second term minus first term, that is 23 minus 15, we get as 8. Then the common difference D, A3 minus A2, third term minus second term, that is 31 minus 23. This is also equal to 8. So we are getting the same common difference here. So that means the given list or the given situation, we can write this 15, 23, 31 and so on forms an arithmetic progression series. We can say in this way. The first one. Now we can see here, for example, now we see the second bit here, the amount of air, the amount of air present in a cylinder when the vacuum pump removes 1/4 and 1/4 of the air remaining in the cylinder at a time. That means in the cylinder whatever air is available, At one time, it will remove 1/4 of the available air in the cylinder. That we can say. Now we have bit number 2. We will see here. Suppose we are having a cylinder here. In the cylinder, there is some air available. We don't know the volume of this air, right? We will first consider let the amount of air in the cylinder is equal to x. Initially we are considering this as, we can say volume as x. So this is our first term. What is this? This is our first term. Then what about second term? We will get in the series. From the available air, we are removing 1/4 of the available air. So the available air is x, right? Minus 1/4 of x. So if you solve this one, what will get here? This is x minus x by 4. So if you take LCM, we get as 4. 4 into x is 4x minus x. So you have to multiply this 4 with this one, then minus this one. So we have here 3x by 4. What is this? This is the second term. Now, after removing this much portion, so what we will get here is 3x by 4. Right? This is after removing 1/4, we will get 3x by 4. So initially we are having full as x. Now we are having second term 3x by 4. Now, what about third term? Third term is from 3x by 4, this is available now, 3x by 4 is available now. Here we have to remove 1/4 of 3x by 4, right? 1/4 of 3x by 4. So once you solve this, you will get the third term, 3x by 4 minus 1 into 3x is 3x divided by 16. So here, if you take the LCM, 4 and 16, both are in the same multiplication table, we get the bigger one, 16. So 4, how many times here? This one, 4 times. 4 times, so you have to write 4 multiplied by the numerator, 3x. So we get here 4 multiplied by 3x minus 16. This one, how many times? 1 time. 1 multiplied by 3x. So here we are having 4x minus 3x by 16, that is x by 16. So third term is how much? No, 4 times 4 3 is 12 we get here. 12x. So 9x by 16 we will get the third term. So this is A3. So we are getting A3 as 9x by 16. So what about the series now? The terms are x, 3x by 4, 9x by 16 and so on. Now we need to find the common difference. How we have to find common difference? Second term minus first term. If you take this one, we have to remove this one. D we get as A2 minus A1. So what is A2? 3x by 4. What is A1? X. When you solve this, what will get here? 3x minus 4x by 4. That is equal to 3x minus 4x. Since 4x is bigger, we get here minus x by 4. This is second term minus third term. Now, when we do another difference, A3 minus A2. A3 minus A2. So here this is A3. A3 minus A2. So we have to do 9x by 16 minus 3x by 4. So what we get here? 16. 16 means 16 one time. 9x you get here. 4 for the 12x. 12x by 16. So how much this is? minus 3x by 16. So here now what we can observe, for a2 minus a1 we get as minus x by 4. For a3 minus a2 we get as minus 3x by 16. Since they are not same, right? Since they are not same, that is common difference is not same here. We can write, since common difference is not same, they are not in AP, arithmetic progression. So to be in arithmetic progression, what we have to do? We have to find the series first, the terms, first term, second term, third term. Here we have found the first term as x, second term as this one, 3x by 4. Third term we find as 9x by 16. Then we find a2 minus a1 here. We get like this, a2 minus a1. Then we found a3 minus a2. We found this as minus 6. Since these two are not same, common difference should be same to be in series. So the given situation is not in arithmetic progression series. This is about question number 1, first bit and second bit. We will continue in another video. Subscribe and share this channel. If you have any doubts, you can mention in the comment section. Thanks.